So my name is Gregoire. I'm a research scientist in the Llama team at Meta in Paris. Today I'm going to discuss a bit how we went in a few years from great models at image classification to models that perhaps tomorrow will lead us to AGI. So first, a few words about Llama. This is Meta's LLM. This is a family of models, a lot of different sizes to mimic my colleague just before me, models that are able to handle text, but also other modalities like images. And that also comes with a stack that allows easy deployment in companies or even at home. So today what I want to discuss is how, first, why are people doing LLMs? What does it work so well? How LLMs will be the brick that allow us to build AI agents, and where will that lead us potentially? So around 2014, people realized that deep neural networks were actually pretty good at image classification, and the recipe was always the same: data in quality and in quantity, and that led to always better performance. And this conclusion was not only true for images, but also applied to other domains like text. And it was especially true when people found that if you pose most problems in text in form of a sequence, okay, so if you move from classification on the left for this movie review, so is it positive or negative, to just asking a question to your LLM about the movie review, you're actually able to put many problems under that form. Translation, information gathering, summarization, etc. And you're able to benefit a lot from scale. And this is what led to success of early models like BERT. And so then the story was pretty much written. Simple methods, lot of data, method that scale, and you get to even better performance, which was what gave us GPT, Gemini, Llama, and all friends. So this story, you know it today, I think. Something that is changing is that we are actually moving away from chatbots and towards true AI assistants. In fact, LLMs are excellent at generating texts that can also generate structured outputs, code. But in fact, nothing prevents me from executing this code. Okay? So for example, here, if I ask a model, what is the Prime Minister of France, a model that was trained, let's say, before 2024, the model will not know who the Prime Minister is today. But if I ask my model to write a query for a search engine, and I execute that query, then my model can have a proper answer. Okay, so by giving tools to language models, which is something that was studied a lot 1 or 2 years ago, you expand significantly the scope and the capabilities of your model and the range of problems that they can solve. And so when you give your LLM tools like code execution, the web, any API, you start to have actually a pretty decent AI assistant. And this is what we showed, for example, in the Llama 3 paper, where we taught Llama 3 to use a search engine and a code executor so that Llama is able to, for example, solve data science competitions. So that was last year. Today is 2025. What's next? Actually, I showed you that it was possible to give tools to Llama or other LLMs to solve a task for which it wasn't trained. Actually, I can go even further and ask my model to realize and solve longer sequences of actions and more complex plans. And so instead of asking who is the Prime Minister of France, I can ask for the whole list of all Prime Ministers of France, given some conditions. So something that will take probably a few minutes, if not hours, to a human to realize. And in my example, I consider only tools that are read-only, but I could also give access to tools that modify the state of the world. For example, I could give access to my LLMs to actions on the web, like filling a form, sending emails, messages, etc. And this is not only about tools. I can also increase the context size of my LLM, so give it some memory, make it able to personalize. And so more and more, what we are doing in the field of LLMs is moving away from these chatbots and make them become truly general assistant and agents. One interesting consequence is that this actually opens a lot of new topics. For example, it's safety. Safety was, in LLM, safety was your model to be unbiased and quite friendly. When it comes to agents, friendly will be about not hacking websites, which is quite a different topic. Of course, new capabilities call for new evaluations. And so with my colleagues at Meta, we worked on new ways to evaluate these AI agents that are able to go on the web. We proposed a benchmark called Gaia, where you have to solve questions that are quite simple, but that actually require to go on the web to find the answer. No memorization is possible. And these tasks, interestingly, are all very simple for a human, for a patient human, but quite difficult for LLMs. And so at the time, GPT-4 was getting ridiculously low accuracy. So this was one of the new ways to evaluate AI agents that has become quite successful because 2 weeks ago, when OpenAI introduced their deep search feature, they evaluated actually on our benchmark. So today we have LLMs. They are pretty decent at using tools for a reasonable period of time, perhaps a few seconds, a few minutes, which is already completely spectacular compared to what we had a few years ago. So what's next? Part of the answer is what we call scaling inference time compute, which consists in giving more time for your model to reason and solve the question, and that will hopefully make them better agents. So where does that lead us? This year, perhaps next year, we'll have models that are decent remote coworker, able to work for you a few minutes, a few hours, and perhaps in the future more. Recipe still the same, scaling data, scaling compute, in pre-training, post-training, inference. But my profound conviction is that we are far from saturating. And so to finish, I asked GPT-01 to craft a joke using reasoning capabilities that summarize the talk, and so this was what it did. A few years ago, AI could barely distinguish between a cat and a toaster, and today they are able to call the vet on your behalf to schedule an appointment for the cat. Thank you very much.